Hi, Katora and Aaron. I am going to do a quick video to show you how to do these problems since we seem to be having trouble with them. So hopefully this screen recording is working and all. So I'm going to walk through the evens. So let's start with number 2. These first triangles that we're going to do, I'm going to really do these fast, so my triangles may not look very good like that. Okay, so this one has a side height. The hypotenuse we don't know. This side's 13, this side is 4. And the angle that we're trying to find is theta. Anytime you're trying to find an angle, you use the inverse function. So we would say what we have with the angle, we have an opposite and we have an adjacent. So we think about our SOHCAHTOA, and which one has an opposite and an adjacent? That would be tangent. So we have OA, so we use the one with OA. So we say the inverse tangent of opposite of the angle would be 4 over adjacent is 13. So we take our calculator, which I'm going to do right here. I'm going to hit second in tangent, and I'm going to do 4 divided by 13, enter, and I get 17.1, which is the same as they have on the answer key. So 17.1 degrees. Okay, number 4. This right angle now is down there, and our sides are 11.9 and 10. Here's theta. What do we have? Again, we have opposite and we have adjacent. Same idea because we don't have the hypotenuse. The hypotenuse is the side opposite the right angle. We don't have that one, so we can't use this one or this one. So let's just do this one's the same thing. So we'd say tangent of inverse tangent of theta is opposite 11.9 over 10. Whoops, I shouldn't have read it like that. So we would say inverse tangent of 11.9 over 10. We just put that in our calculator. Second tangent 11.9 divided by 10, and we get 49.958. So they're just saying it's 50 degrees. Okay, let's just keep moving along here. Number 6, we need something different. Here we go, this one's different. Here's a right triangle. So this time we have, here's our theta. This is our hypotenuse, and it's 5, and this side's 4. So we have, if we're talking about our angle, we have adjacent and we have hypotenuse. So if we think of our SOHCAHTOA, we have the so we're going to use cosine. So we'd say inverse cosine of opposite, adjacent, which is 4 over hypotenuse. So we just hit second cosine 4 divided by 5, and we get 36.869. So we're going to do 36.9 degrees. And then number 8, let's look at this one. We got the right angle down here. Again, we have, okay, no we don't. We don't have a hypotenuse again. So if you don't have the hypotenuse, you can't use this one or this one. So we're going to use TOA. So we use the inverse tangent of 3 divided by 3. And I know this is going to be 45 degrees because I know that tangent of 1, opposite, or inverse tangent of 1 is 45. But let's just do that. Inverse tangent of 1 is 45 degrees. All right, so if you look, none of these are sine. Oh, no. Yeah, adjacent. Okay, number 5 is going to, nope, that's tangent too. So I don't see any of these that are sine. Interesting. Okay, let's go to the next part. So we're hopping down to 10. Now they're going to give us the angle, and you have to find the missing side. So here we go. We have 13x, whoops, we had an angle there. I'm trying to go too fast, I think. 32 degrees. So we have 13 and x. Again, we don't have the hypotenuse. So if we're talking our SOHCAHTOA here, we can't use this one or this one because we don't have the hypotenuse. So we're going to use tangent. So we use tangent of 32 degrees. Now we know the angle, so we put it in there, is opposite over adjacent, which is 13. We put tangent of 32 in our calculator, no inverse this time, and you get 0.625 equals x over 13. We're going to cross multiply. We're going to take 0.625 times 13, and we get x equals 8.12. So they have 8.1, okay, which is what we have. All right, next one, 12. It's the right angles down here this time. We have x 11, whoops, that ended up being an 8, x 11, 60. Okay, what do we have? Here's our angle. We have the hypotenuse, so we have h, and we have adjacent, so we have a, so it's going to be cosine. So we'd say cosine of 60 degrees equals adjacent over hypotenuse. So I'm just going to do cosine of 60 in my calculator. Cosine of 60. I'm going to multiply it times 11, all in the calculator at one point. If I could hit the right buttons, that is. And so we get x equals 5.5. Let's move on to number 14. 14, right triangle. Here we go. We get x 57 degrees, 10.8. You can see I'm in a hurry here. So what do we have here? Here's our angle. So we have the opposite. This is opposite. So we have O, and we have the hypotenuse, which is opposite the right angle. So we have the So we're going to use sine. We're going to say sine of 57 degrees equals opposite, which is 10.8 over hypotenuse. This one's tiny bit harder. We're going to cross multiply, so we're going to get x sine of 57 degrees equals 10.8, and then we're going to divide both sides by the sine of 57. Sine of 57, so you can just put this in your calculator, 10.8 divided by the sine of 57, and we get 12.9. So we get x equals 12.9. Shimmy down here just a little bit. One more of these, and then we'll go on to the last part. 16, we have a right triangle. We have 47 is here. The hypotenuse they give us is 3, so we're either going to use the so or the ca, because we have the hypotenuse, and we have the side adjacent to it, not opposite. We don't have that, we have the side adjacent, so we're going to use coa. So we'd say the cosine of 47 degrees equals adjacent over hypotenuse. So again, we're just going to cross multiply. We're going to say the cosine of 47 times 3 equals 2.04, and they have x equals 2. All right, last part. Number 18, solve each triangle. This time it's a variety, I guess. No, it looks like the same thing as we just did. Actually, I'm not sure what these are about. Let's see, maybe we can't do these. 18, so we have a right triangle, such as this. We have 9, 51, oh, okay, 51 degrees. They want you to get all the sides. That's what they mean by solve it. So we'll call this one x and this one y, just so we have some variables. So the first one is we have the adjacent, right? I mean, we have the opposite. Let's get x, so that's adjacent. So we have opposite. If we're getting x, we have opposite and adjacent. So we're going to use tangent. So we'd say the tangent of 51 equals opposite, which is 9, over adjacent, which is x. So we put that in your calculator. We're going to say x tangent of 51 equals 9. X equals 9 divided by the tangent of 51. Put that in calculator. 9 divided tangent of 51. So we get x equals 7.3. And then we're going to get y, which is hypotenuse. So now we have, if we're getting y, we're going to be using the opposite, and we need the hypotenuse, which is y. So we're going to use so. So we're going to say the sine of 51 degrees is equal to opposite over hypotenuse. So it's going to be y sine of 51 equals 9. And we'd say y equals 9 divided by the sine of 51. So 9 divided by sine of 51 is y equals 11.6. Okay, and these are in inches because it gives you a unit. All right, let's try another one. So number 20. Hopefully this is all making sense to you guys. Here's the right triangle. We're given this one is 53, and this time we're given the hypotenuse. So since we're given the hypotenuse, we're either going to use so or ka. So or ka. So if we call this one x, that would be our opposite. So that would be our so. This is our x. And if we're trying to find this one, it's our adjacent. So this would be our y. So we'd say the sine of 53 equals opposite, which is x, over hypotenuse, which is 5. I'm not going to solve these from now on, just so we can get through them. And then we would say the cosine of 53 equals adjacent, which is y, over hypotenuse. I think you guys can solve them from there. Okay, 22. Right triangle such as this. So we have the hypotenuse again, 14 miles, 24 degrees. If we call this one y, this one x, we know that we have the hypotenuse, so we're going to use so and ka because we have the h. So we use those two. So we'd say the sine of 24 equals opposite, which is y, over 14. And the cosine of 24 equals adjacent, which is x, over 14. And the last one, 24. I didn't want this video to be boring for you anyway, so hence the speed. And tomorrow I can answer any other questions you have. 28, we have 6. So we do not have the hypotenuse, but we need to find it. So we'll just call this one, let's just call this one h for hypotenuse, and we'll call this one for x. So we say sine, so we have the opposite, so we're going to use sine. So sine of 28, whoops, we can't use this one. Look what happens. Opposite over hypotenuse. Whoops, ding, 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 ding. That doesn't work. We don't have enough information. So let's start out with cosine of 28 equals adjacent over hypotenuse. And then we only have one variable, so you're going to solve that one. And then to get x, we're going to have to use tangent. So we'd say the tangent of 28 equals opposite over adjacent. And you would solve that. So hopefully this video was helpful to you. Just email me back and let me know if you were able to finish the worksheet or not with this help. So I'm going to try to cut this video off, put it on YouTube, and get it out to you. So talk to you soon.